Hello, my name is Yuriy Slashchev, and I'm a senior in electrical engineering. This summer, I'm working with the University of Arizona down here in Tucson, the land of cats, vehicles, and cat vehicles. No, I'm sorry, there's been a misunderstanding. Cats have not yet gained the right to drive. A true tragedy of the modern era. Instead, I'm referring to the University of Arizona's very own self-driving car. Let's take a look. And here we go, the cat vehicle. So what exactly are we doing with the cat vehicle this summer? Let me explain. Now when you get your license, they make you take a vision test, right? Makes sense. How can you drive if you can't see? Same thing goes for the cat vehicle. How can it drive itself if it can't see? But how does a cat vehicle see? How does any autonomous vehicle see? Simple. We equip it with a whole slew of complicated sensors, such as
traditional image cameras, a two-dimensional point laser made by the company SICK, and, most importantly, a three-dimensional Lidar made by the company Velodyne. Wait, let's back up a second. What is a Lidar? Well, the word Lidar is made out of the words light and radar. This Lidar sends light out into the world and collects the reflections, giving you a three-dimensional cloud of points that allow you to see the world as their true 3D shapes. But why did I call it most important? Well, because that's what me and my team are currently working on. Let me explain. Our research is based off an experiment done with the cat vehicle last year, where it was shown that a self-driving car can actually reduce traffic if you can control its speed properly. In that experiment, the cat vehicle followed the other cars by simply following the closest point in 2D data, and the speed of the other vehicles was tracked with a 3D camera in the center. Here's where we see the room for improvement. We have the sophisticated 3D technology, but why can't we identify and track other vehicles with it? That way, we can make sure we're actually following vehicles and not cats. And we can all track the speed of the other vehicles, all from the car. And that's our goal, to identify and locate other vehicles using the 3D LiDAR data, and then to track their speed. Now what's my role in the research? The very first part, identifying the vehicles with that 3D data. So how does it work? My method is as follows. I read the three-dimensional data in from the spinning LiDAR on top. I take that data and align it to a grid. I then classify each box of that grid as being either noise, part of the background, or part of the foreground. I then connect parts of the foreground that have similar heights, resulting in clumps of points called blobs or objects. I then use a model I've trained to distinguish clumps that represent vehicles from clumps that don't. I then find the centers of those vehicles and send them over to my coworker's code for tracking. All of this is part of the 10-week cat vehicle research program funded by the NSF, the National Science Foundation. This has been a great experience from start to finish. I've had a chance to work with a great team, great mentors.
see the highs
and the lows, of this great city of Tucson. I've seen some of Tucson's most interesting sights from top to bottom, and everything in between. I've tasted every part of America's first capital of gastronomy.
There we go.
Believe me, every part. I've learned so much from so many, and most importantly, I've made friends and had fun. I take away with me a deepened understanding of what research and teamwork are really all about, and I also take away with me an experience that I'll never forget. I'd like to thank my faculty, my team members, my friends here at this program, the University of Arizona, and my professors back at home, all for giving me this great chance. Thank you. Good night, and good luck.